Section 7.9 is about square root functions and inequalities. A square root function is a function containing the square root of a variable. Now, for it to be a function, it has to pass the vertical line test. So if you look down here, you'll see the green is the graph of a square root function. Except y equals positive and negative square root of x is not a function. And the reason it's not is because it doesn't pass the vertical line test. I can put a vertical line test there, and I can see that the positive and negative version is not a function. However, y equals the square root of x, that is a function. Because as long as we stay positive, which is shown here in green, then we pass the vertical line test, and it is a function. Now, in order for a square root to be a real number, the radicand cannot be negative. So having numbers that are under the square root that are negative, that's a big no-no. So when you graph these, you want to determine when the radicand would be negative and exclude those values. So make sure when you have a square root function that you don't use any numbers underneath the square root that are negative. So here's an example of a square root function. I want to state the domain and the range, and I also want to find the x and the y intercept. Well, the domain is all the x values that I can plug in. And since I can't have the square root that's a negative, I know that 3x plus 4 has to be greater than or equal to 0. That's where I want to start, because I can't use any negative values. So if I solve this by isolating the x, divide by 3, I have x is greater than or equal to negative 4/3. That is what my domain is, because I can only use x's that are bigger than negative 4/3. Now, because I can only use x's that are bigger than that, that also means that my x-intercept is 4/3. Or I should say negative 4/3. That's where, that's the x-intercept, that's the spot on the x-axis where it's going to touch. So let's go over here and say negative 4/3 is negative 1 1/3, which is about right here. So that's where my graph is going to touch the x-axis. That's the x-intercept. And I know I can only use numbers that are bigger than or equal to negative 4/3, so that's my domain. Now let's do some table of values to see what I get here. So x, so if I plug in, how about negative 1, because remember I can't go any lower than negative 1 1/3, so we'll go negative 1, which will give me a negative 3 plus 4 is a 1, and the square root of 1 is 1. We'll try a 0. 0 plus 4 is 4, square root of 4 is 2. We'll try 2. 2 times 3 is 6. 6 plus 4 is 10. So my y is a square root of 10. We'll plug that into a calculator to get a decimal approximation and say that that's about 3.2. Let's plug one more in. I know if I plug a 4 in, I'm going to get a 12 plus 4 is 16, and the square root of 16 is 4. So I'll plug that one in just because it's a nice whole number. Now we'll graph these. Negative 1, 1, 0, 2, 2, and then about 3.2. So about there, and then 4, 4. And if I graph this with a smooth curve, you can see it's looking like that, which is what a square root function looks like. That's at least the positive half, because remember we can't have the bottom half, otherwise it won't be a function. So what is the range here? If this is my domain, what is my range going to be? What are the y values? Well, we can see that the y's increase and go off forever. So we can say that all the y's are going to be greater than or equal to 0, because you can't go lower than 0, so my y's need to be greater than or equal to 0. So there's my range, and then the last thing it asks for is the y-intercept. Well, we know when we plug in 0 in for x, we get the y-intercept. So here's my y-intercept at 0, 2. And you can see that right here because that's where the graph touches the y-axis. Now we'll look at a square root inequality, which is nothing more than an inequality that involves square roots. Like every other inequality that we've graphed, you start by graphing the boundary, and you replace the greater than or less than sign with an equal to. You graph the boundary, and then you figure out shading. So first I want to find out what negative values I should not use. So I'm going to solve this for x. So I know my domain is bigger than or equal to 3, so I know that my graph is going to start here on 3, and I know it's going to get bigger than that. I'll get a couple of points just so I can graph this and make it look nice. Since I know I'm going to be bigger than 3, I'll plug a 4 in. 8 minus 6 is 2. Square root of 2, it's about 1.4. Do a 5. 10 minus 6 is 4. Square root of 4 is 2. Let's skip to 7 for no good reason. That's a 14 minus a 6 is an 8, so square root of 8 is about 2.8. So we'll graph those and get a sketch. Here's 4, 1.4, 5 and 2, 7 and 2.8. And we'll sketch this. Now when we sketch it, we're going to sketch it using a dotted line because we're talking about a boundary line now. So this will be a dotted line, which means the line itself will not be included. But now we have to figure out shading. So I'm going to pick a point either under the curve or outside of the curve. Now I've got to stay greater than 3, so I can't choose 0, 0. So I'm going to try 5, 0 because I can't. My x's have to be bigger than 3. So I'm going to plug this back into the original. 2 times 5 is 10. 10 minus 6 is 4. Square root of 4 is 2. Is 0 less than 2? That's true. So I know that 5, 0 is in the true side, so I'm going to shade everything underneath my curve, and I'm going to use x equals 3 as kind of a boundary, because everything under this curve will work. Every point goes down here to infinity. For this one, I suggest that you pause the video, try to do it yourself, then come back and see what yours looks like compared to mine. So here I'm going to start by making sure I use positive values. So x plus 1 has to be greater than 0, which means I'm using only x values that are greater than negative 1. So I start on x is negative 1, put a dot there, and then I try some more x values. 0 gets me a 1, 3 plus 1 is 4, square root of 4 is 2, and then I plugged in 8 also because that gave me a 9, and I knew the square root of 9 was a 3. So I plugged those points in, I got some dots, and I'm able to see that my square root function looks like this. Now, because my x went all the way to negative 1, I could try 0, 0. Yay! So I plugged in 0, and I've got a false statement, which means 0, 0 is on the bad side. So I'm going to shade everything above this line, but I'm not going to go any further left than negative 1, because the domain can't go left of negative 1, because that gives me negative values for the radicand.